thank you very much for the panels. I think I know some speakers already spoke earlier, but I think it would be good to have a brief introduction in case some of the audience just came in. I know there are people arriving late and the train, whatever delays. So can we have a round of brief self-introduction from the panel? Whatever order you prefer.
Yeah, I can go first. So I'm Jonathan Carter. I'm an ENCODE AI for Science Fellow at the University of Oxford. I work on physiological foundation models. I've also previously spent a few years in industry in health tech, and so I've been involved in the development of a number of different AI-enabled medical devices that have been approved by the MHRA for things like sleep tracking and infection risk prediction.
Hi, everyone. It's me again. It's Chris Barnes from NPL, Head of Science for AI.
Hi, I'm Julia Hirschberg. I gave a talk earlier. I'm at Columbia University and haven't been in industry for a good many years, so I'm very interested in all the things that have changed.
Hi, I'm Henry. I'm a co-founder and CEO of Cultivarium. We are a focused research organization out of Boston, Massachusetts. We do interact quite a lot with industry. We do a lot of basic science, fundamental science, but we do all of that work with industrial-grade resources.
Hi, everyone. I'm Tom Pollard, also out of Boston, Massachusetts, at MIT. We'll be talking tomorrow about some of the work that we do, sharing health data for people like you, people working on AI for health.
Us as well. I have a mic.
Oh, sorry.
Thank you. Hi, everyone. My name is Farah, and I'm an assistant professor at NYU Abu Dhabi. And I lead the clinical AI lab, so we work on medical problems, lots of multimodal AI, which I'll talk about tomorrow. So we're very grateful for Mimic. And I also did my PhD at Oxford, so I have a connection with Oxford.
Great. We can see that we have very diverse and excellent panel here. We have two preset questions here, and if we have time, we can invite more questions from the audience later on. The first question is what kind of community outputs will most help multimodal AI move from research promise to real-world deployment? I know Chris has covered some of that in particular detail, and there are many points that have been raised in earlier talks. Can the panel further elaborate? What kind of output do you think can really help us to move from research promise and lab and papers to actual real-world deployment for impact? Who want to speak first? I think whoever wants to speak, you can grab the mic here, please.
Everyone's looking at me. Okay. So I already said a couple of things around data. I think data and Mimic obviously being an excellent example. So data sets that are clean and traceable, that adhere to those standards. So 5259 is the one, or other standards. I think they're really important to produce, and we've seen competitions and things like that really accelerate machine learning in various areas, such as computer vision. So I think generating those kinds of community outputs, I mean, that's kind of obvious, that one. But I think also, work on different using the benchmarks, but also the metrics that should be used, and studying those as a community.
Tom, I think, from the...
Yeah, I have kind of lots of thoughts going through my head, and I'm trying to work out how to turn that into something that makes sense when I say it. But I think, in some ways, I feel like we know what we need. We need infrastructure. We need, and I kind of think of data as part of that infrastructure. We need people sharing data, because all of us, on some level, are constrained by the data that's available to us, especially when you're talking about multimodal AI, where you now need to bring across these modalities and match them together. And that's a really difficult task. And then we need to think about how are we evaluating the different models that we're building. When we go to a conference now, all the papers are about models. You don't go and see people presenting their work on building. I mean, maybe a bit more now, but in general, 90% of papers are about models that people have either built or applied to some task. But there's no way of doing kind of like-for-like comparison between the models. You go to PubMed and you can search for mortality prediction models using Mimic, and there'll be thousands of papers. But I can't look at those papers and say this is the best model, because every one of those papers has 1,000 different researcher degrees of freedom going on within the paper. How was the data cleaned? I thought that was a great question. How was the evaluation done? How was the population selected? And so we need better infrastructure for measuring kind of what matters. I think the real problem is, we know what kind of things are needed. The academic system doesn't reward that. The academic system rewards papers and then moving on, not deployable, because deployable means a lot of work. Going into a hospital and trying to get someone to deploy your model is a huge amount of work. So I hope that when we talk about the community, we're talking about not just us as researchers, but we're including industry, we're including funders, we're including journals, we're including university faculty who are deciding who to promote. And those are the people that I think need to think about deployability and think about how they change the academic system so that it rewards aspects of deployability.
Thank you. That's really interesting. I really like the comment about research degree of freedom, right? So I hope that in future we can ask that more. I think as a community, right, so you think that we can't do much, but actually you can do a lot because you review many papers, right? If you're reviewing paper, can you just think about that? Ask the author, right? So we're not rejecting them, but just think, okay, how much research degree of freedom you have clarified, right, in your paper, and can you clarify how much of that, and that can help us to get better understanding of the changes you made and how to compare across model, whether that's fair and so on, right? So I think that's some comments that very, very inspiring. Yeah, Henry, you.
I just had a question, a very basic question, which is how has AI changed all this for industry?
Who can answer that question? People from.
Sorry, you go.
I can speak a little bit on that. It depends on
what does AI need that is different now,
sure
besides more AI.
So before I dive into trying to answer that directly, I also wanted to try to address Haiping's question. So you mentioned two terms that I think we need to just, sorry to be the pedantic one, but you said deploy and impact, right? And I think there's a load of words, there's a load of meaning behind those words. I deployed a model on railway just this morning, right? I don't know what impact that will have. We need to think about within the research community or communities at large working in this space, there is a lot of work to be done on benchmarks, evaluations, these types of things, but it's almost an infinite game of model building. And so you have to ask yourself, are you in the process of learning how to build models and how to evaluate them? And are you in the game of infinitely building newer models? And who are you competing with to do that? There's a world where there's lots to be researched, lots to be improved on models, but then if you're thinking about impact, I would say that what limits impact today, going back to your question, what does industry need? Well, it also depends on the type of industry. Metrology, we probably shouldn't rush AI development or adoption. There's some really great reasons why defense or standards should be kept at maybe a late adopter stage. I think that makes total sense. And I'll give a talk tomorrow morning where we are quite the opposite. We aggressively and just to be a little scandalous, maybe irresponsibly adopt all AI tools just to try to determine the edge. And the way that we try to get people to adopt AI is either directly where we can say, we have processed this amount of data, you can get the results, and you have to evaluate if it's useful for you. But we have done a lot of the compute and the sorting through, sorting through all of this information. We've done a first layer. Or, so we just basically serve up the results. So you would then ingest the secondary outcome of the AI, right? Or we can say, all right, you can try this AI tool and you tell us how well that works. In this day and age, it's really hard to get anyone to adopt your specific AI tool, right? Everyone has their own AI tools coming out. So I think you have to be very careful and explicit on what does deployment mean, what does impact mean, and then where in that 2D and much more complicated energy space do you want to be in?
Excellent comments. I'm thinking about what you mentioned about what the industry needs, right? That's this question. I'm thinking about as a community, actually, we can organize these kind of panels or discussions. We can organize sessions. We just invite the industry, just speak out, right? So what do they need? Because I think mostly we are listening to academics talking about. That's why I really appreciate Henry and Jonathan, with some kind of industry background joining us. I hope that through your network, I also appreciate Niadi, right? So I think that's through our really network, we issue funding calls and we require our applicants to have an industry partner, and that's how we try to get people from industry to come to our community and provide their input. I just feel that we need to do that a bit more, and probably in collaboration with other people like MPL and Cultivarium or MIT, whatever, right? So I think we need to have more kind of focused discussions of the question that we rarely think of or discuss, but we know that is quite important. Yeah. Thank you very much, Henry, for the comments. Any further comments from the panel?
Yeah, I was. Sorry.
Yeah.
Go ahead.
Okay. I was just going to follow up on what Chris and Tom were saying. I think another thing that we need more of is a shift. I think as we increasingly apply, these AI systems to more open-ended problems, there is a need to go from static to dynamic benchmarks. So what I mean by that is, for example, Tom was talking about, there's tons and tons of risk prediction models that you'll find online. And the way that those models are trained is that, they'll get a retrospective data set where, you can label whether somebody has an infection in 7 days' time. And then, you can treat it as a supervised learning problem and train a model to try and predict that. But the problem is that it's not a supervised learning problem, it's a reinforcement learning problem. So if you have a model that predicts infection, and then you deploy it into a hospital, and it suddenly starts pinging that somebody's going to get an infection, you then load them up on antibiotics. They don't get an infection, and then suddenly it looks like your model is not working because your evaluation metrics of whether it predicts an infection suddenly go to zero. I think there's a need to shift from kind of in those sorts of problems there's a need to shift from kind of static benchmarks to dynamic benchmarks, and a need to more closely scrutinize whether the metrics that we're actually tracking in our machine learning papers actually correlate with real world value anymore. It's kind of going back to the Goodhart's law comic that I think you had on your last slide. Yeah. Yeah. Thank you. That's very, very interesting comments and very insightful comments. When you are talking, I'm thinking about actually as a community, probably we need to try to come together and formulate some kind of grand challenges or like open problems that we think as a community, many of us we care about, right? So then we can, even if we have limited resources, probably we can tackle them one by one or focus on a few, because I feel academia are too much fragmented. Everybody working on their own problem. They think, I think that's probably something we can consider to consolidate this discussion and even carry on the discussion in network reception follow-ups to come out with something tangible. And after 1 year or 2 years or 5 years, we can come back. What come out from this panel discussion and this network, this workshop, can actually carry forward to have something really tangible and impactful.
Probably Farah can comment.
So I just wanted to.
Sorry.
No worries. I just wanted to go back to the point about data. So one example I'll give is even for my PhD, I was looking at specifically early warning score models. So for those of you who are not familiar with EWS systems, these are alerting models present in hospital wards that look at heart rate, blood pressure, temperature, oxygen saturation, etc. And it's a very simple like risk calculator, basically. So based on your vitals, you would get a risk score, and that indicates, let's say, the risk of deterioration. And even though those were developed even pre-machine learning and AI, they're commonly used, and they're even used in hospitals in the UAE where I'm based. And we've had studies that have shown that these early warning systems, even though they're simple, they actually don't work well in cohorts that are not similar to the training cohort, because they still develop them based on heuristics, and they were developed in the UK. But my point here is that even with the AI models that we're developing now, and we're relying a lot on Mimic, just because Mimic is a great resource, it's multimodal, it's large scale, etc. Once we start thinking about real-world deployment, we need to also start thinking about generalizability to more diverse settings, because we don't want to fall into the same trap of relying on models that were developed for other cohorts, even though they were much simpler models, but just don't work well in other settings. So I think my answer to that question would be we do also need more diverse data sets, even if they're not sort of development or training focused in terms of scale, because I understand there are a lot of privacy concerns. We can even think about creating diverse validation data sets such that they're more manageable in size, and because I know it also requires a huge effort in terms of maintenance and making sure that the data set is well hosted. But I think that could also be an interesting community challenge.
Yeah, great, Farah. Thank you for your input. When you are talking about quoting the examples, I'm actually thinking about something we talked about yesterday in our AB meeting. It's about some kind of case studies or use cases or even stories. Right? We all know we grew up listening to stories, fables. Try to learn something. How about our community? Do we have kind of stories? For example, Mimic, everybody using it. But what is the story of a Mimic? What we can learn from? What's the moral of story of Mimic? And what about other examples that are related and can give us kind of inspiration and something we can make analogy with, and something we can, if we can have a collection of like a book or story, right? So I think as a community, that's something actually easy to do. And through the interest group we are about to launch, activate, probably we can do something like this, a collection of stories or use cases or case studies that we can put together, that we can go through some things. We can even have talks, conversations, talk about it. I think that would be something really interesting and exciting, right? So particularly for growing the community and also break the communication barriers. We know, I think, from the hackathon yesterday, we know many of us are very technical, good at coding, programming, but that communication, right? How to tell things in a more accessible way is still quite lacking. I think if we have the community output that we may want to come together to curate like a storybook for multimodal AI, that would be quite interesting, I believe. Yeah. Any other comments from the panel on this question about outputs, what we want, what industry want, what academia wants, what jointly academia and industry want?
I mean, when I read your paper on this, suggesting that we needed to move to deploy-centric or deployable-centric models, I loved that idea. I thought it was genius, because I think I was kind of in my mind, we'd moved from this model-centric to data-centric. Everything is about the data now. But actually, thinking about deployability, I think in some ways when I think of deploying, for me it kind of ties to impact. I'm only going to put effort into building a model. I feel like the deployability aspect ties very much to a use case and to doing something that is useful. If I'm thinking about deployability, I'm not just building another mortality prediction model, which is not what the world needs. If I'm thinking about deployability, I'm thinking, well, what actually does, in this hospital, what do they want? And, how do I make sure that I build that? I think it also provides a very useful constraint, because there's always that kind of more modalities or more data that we can add, we can always make our models slightly better and better by adding more data. But if you're thinking about deployability, you're adding a constraint, which is there's a reason why parsimonious, simple models are popular within hospitals. When you go into the hospital, they're not using fancy AI algorithms most of the time for prediction. They're using models, like the early warning scores, where they have 5 variables and you can calculate it, with a piece of paper. So, thinking about deployability also makes us think about constraining ourselves a bit and not just throwing all the data in and saying, let's use that. Because, in reality, us as a researcher can build a model with a high performance, getting all the data. But in a hospital, that's not going to work. It's going to be extremely brittle. There's going to be lots of problems you come across relating to, shortcut features, to the complexity of having too much data.
Yeah, that comments just, we see lots of things on social media when we promote our work, including, right, we always say, okay, we have a breakthrough, has something great coming out. But when you actually living in real life, when you see doctor, when you go to the hospital, I think we really experience, right? So I think academia research is very optimistic, right? So I think sometimes over optimistic. We think, okay, we solve the problem, whatever. I think, but the kind of disconnection is becoming bigger and bigger. I think you will live. It's more like social media, right? So you live in your own world of illusion about we are getting more and more powerful, but the real world is crying, right? So I think that's really, really important for us to really reflect this more like system. Yeah, everything. Yeah, Chris.
Yeah, I think that's a great point. I'll just following on from Tom's comment. In a way, the way it's done right now is the opposite way around. The safe and trustworthy AI life cycle that I pointed out, I didn't make it clear, that's done at the start. The developer sits down with the clinician and the public health people, and it's designed for that deployment in mind. A lot of the time we don't do that because the clinician will turn around and go, well, I just need this simple thing. And it's not exciting from an academic point of view. But it needs to be thought of at the start. There's no point developing things and then going in and saying, is this useful? So I think need to think about, getting clinicians in or material science or the people from industry to co-create projects,
Yeah, I think that's a very important comments, and they also help us to reflect what we can do, because that's what the community can do the most. Because I believe some of the early career researchers, they may want to do that, but they don't have that kind of network or connection. Like because I came from lecturer, from senior lecturer to professor. I know in the beginning, if you want to find out some partners, it's really difficult. But I think that's probably one of the big role that this community and the interest group that we are about to create can play a big role, so that when people want to think about do this kind of deployment first thinking, right, before they start their project, they can have somewhere to have access to this kind of network or comments or input to help them to position their problem better, right? So I think many of the PhD students, they are starting their project, but they really don't know what kind of problem that they should work on and so on, yeah.
Sorry, another point is, I'm not just laying the blame at academics. Also, industry could better communicate the challenges that they face. Like, problem books I came across recently. The police have one. AI Security Institute has one. You could encourage, the industry, different sectors to say, what are the biggest challenges that we need to solve? Write them down, and then, then academics would know the types of problems to tackle. You don't have to exactly solve a problem for a company, but working in the right kinds of areas that are missing, and there are gaps in the knowledge.
Yeah, that's a great comment. I think I don't know whether Peter is here. Peter Charlton, are you here? Yeah, so Pete has reminded me when I write a proposal. He reminded me of something Alan Turing Institute have done very well is the Turing way, right? So it's an open. We believe the kind of story it should be dynamic, right? It shouldn't be static, right? So because it should be like software, you need to have version controls. You need to update it. We know some information may be wrong in the beginning. Also, because if it's static, then people will. Many of ourselves are perfectionists, right? So you want to make it perfect, but that shouldn't be the way, right? We have something, we know there's a mistake, something is incorrect, but we put it out there in the world, then the community will provide feedback, we can revise it and can keep it evolving through the time. I think that would be something quite valuable. If we create some kind of the Turing way, we can have kind of a problem book or challenges, whatever. That would be something highly valuable, and that's something also quite sustainable and easy to start, and we also very tangible, right? We can really create some great impact from that. Yeah. Any other panel member want to comment on?
Oh, thanks.
All right. I think we have spent about a little bit 20 minutes on the first question. Probably we can move forward. Mm-hmm. To our second question, which probably the keynote Chris has covered a lot. What evidence researchers should provide before claiming a multimodal AI system is trustworthy enough for real-world use? I think Chris have covered that a lot, but now I think we can hear more comments from the panel, and later we can open the ground to the audience.
So I think I can just start by building on what you discussed, Chris. I think one of the things that we are also working on is uncertainty quantification in the context of multimodal learning. So how do you think about like implementing safety guardrails, which I think are also similar to unimodal settings, but potentially in multimodal settings you can start to think about what kind of uncertainty can also come from how you pair the data or pair the different modalities with one another. And I think that's also extremely important in healthcare because we need to go beyond the metrics that we're traditionally used to, like AURC, AUPRC, etc., and start thinking about metrics that could also reflect real-world deployment. So one of the metrics that we are looking at in this context is, for example, selective prediction. So how does selective AURC change as you defer samples that the model is not confident about for expert review? So these kinds of frameworks are really important, I think, to push things forward from an evaluation point of view. And another angle that we're also interested in understanding better is also the robustness of the system to, for example, data missingness. So how does the system work when a modality is missing or is either unavailable because it wasn't collected, or even with experiments that we have designed in order to sort of artificially create modality dropout. So I think these kinds of things are important because you assess the reliability of the system within a retrospective study, but also potential practical considerations for future deployment.
Yeah, thank you. Very, very insightful comments, right? So the kind of, I don't know whether we can provide a list, right? So I think that's probably NTL is going to do anyway, but I hope we can work together to craft something like these metrics and so, yeah.
Yeah, just following on from that comment, I think one thing we have to think about is it's a socio-technical system that you're deploying. And you just reminded me, actually, I didn't talk enough about that. You also have to consider, if you're in that example, for example, mm-hmm. If you're deferring choice, the difficult choices to an operator, they get fatigue, right? So you have to consider the AI human system. It's not all about just how the algorithm performs. You have to consider it as a system, and I think finance, for all its, for all its faults, actually has it actually treats systems like that, and there's use cases that they can be applied to, and they have regulation in place, and that's one of the reasons why finance is probably the most advanced in deploying AI systems. So I think you have to consider the whole thing when you're thinking about if it's trustworthy or not.
Yeah, thank you. That's I think that's more like a more systems level thinking, right? So, for example, in biology, there's system biology where you have to think about it holistically, not just one point. Yeah, thank you for that comments. Yeah, any other panel want to comment on the evidence that we need to provide, yeah, so that we can claim it's trustworthy?
Yeah, I guess this is more an evidence that I think you shouldn't need to provide. Is I was just, one of the first things that came to mind is, I don't know whether the conversation has moved on, but there was a lot of conversation about interpretability and whether that was necessary. I feel like that maybe still some of the EU regulation has some kind of requirement for interpretability.
Transparency or whatever.
I'm not sure, but I think that I think it's kind of an unachievable goal to expect models now to be really interpretable. So even if it's desirable, it's not something that we can require. And if you go to your doctor, she doesn't. You don't require her or him to explain how your paracetamol works, So we can't, I think, hold models to higher standards than we hold ourselves. So that was just one thing that came to mind. I think that interpretability is probably not something we need. I think the point that you made about continuous evaluation is really important. That you can have a model today that looks great, but it doesn't mean it's going to work tomorrow, and so you need to be able to continuously evaluate. And you need models that are robust to all the different changes that are going on within the environment you're deploying in. We have changing protocols. The changes in the way the doctors operate can affect your models. The lab tests that get done within a hospital can change the results of a model, and you need some way of just continuously kind of trying to evaluate those things and make sure that that the model continues to work over time. One thing that, I'll stop there.
Thanks. I just wanted to maybe have a little space for the discovery side of things. And so there's a lot of folks here working on high liability, high precision, high accuracy requirements. And so, again, those of us on the more discovery side get to just play. Now, one of the things that I will highlight is really this level of evidence and level of trustworthiness. Let's actually take a quick look at AlphaFold, right? So we all name AlphaFold because it's amazing and it has solved protein folding, but actually most people who work in biology don't believe that's true, because there are many classes of proteins that it does not predict well, especially the floppy bits and all the different things without very rigid structures. And so we all think about it as the answer, yet it's not actually covering 100% of the space or even close to 100% of the space. And there are many other models that continually come out. For example, ESM through Meta, et cetera, et cetera. So I think that as you think about deployability or problems worth working on, there's a massive space of things that are hard today because it's rather bespoke or requires a lot of expertise to actually manifest the answer, maybe a singular answer. And so if you can work on problems that maybe the bar is just so low, maybe that's a good way to deploy.
So I can just say that I am working with industry and the medical campus in 2 projects. And we hadn't even thought about this being AI in industry. And it's a very challenging thing. It takes a long time to get new things to come up. But that's what one should do to have really good help for the people uptown who have various problems that really maybe they need AI too. Who knows? Oh, we got it.
I think those discussions just reminds me of something we rely on heavily is Wikipedia, right? So you can always find some kind of balanced view over there, but most papers are very biased, right? Because biased to the author, just like Tom mentioned about interpretability. I don't know whether there's a place that we can see, we can explore the balanced view about interpretability, what's for, what's against about it, what's opinions about it. I think that's really reinforce what we had discussed before, and something I really want. I think we should create this kind of book, kind of online collection of this kind of idea and indexable, and people can really explore. That's something we definitely can do.
Just to come back on Tom's point of interpretability, I think it comes up a lot, and I agree we shouldn't hold models to higher standards, but we do, because, look at self-driving cars. I mean, I think there's been 2 fatalities compared to I don't know how many fatalities per year or per week on the US roads. But I think, the question of transparency, interpretability, it will come down to a law decision at some point. There'll be some. I'm not being doom and gloom, but there'll be some incident where law will make a precedent, and there will a judge or a group of judges will decide if an algorithm needs to be, interpretable. And if it does, then we're all going back to random forests.
So a new profession probably AI lawyers, right? So it'll be lawyers who are specialized in AIs and so on. Yeah, probably.
Just on that note, I feel like also the interpretation of interpretability, I think, has shifted, because I feel like clinicians love anything that produces text. And so if we're just producing some kind of textual explanation of the model's prediction, depending on whether you're actually using the reasoning or if you're just calling a tool, I think that could be sufficient eventually. Or at least this is what I'm observing.
I think that's kind of accessibility, right? Because clinicians, they don't feel, if you don't produce that, they don't feel it's accessible, because they don't feel that you give them a chance, at least, to question you, because you just throw them a result. Say, okay, use it or not, right? But if you provide something like it's more accessible, like a text or whatever, they can actually question you. They at least have the opportunity. They may not do that, right? But that can help psychologically to build the kind of trustworthiness. I think another weakness we identified previously in the room, we also lack people from like a social science or psychology, this kind of background, which they may have more insight about this. Yeah, please stop me.
I was just thinking, I also think we don't, we're not very good at being consistent about how we, report on performance. And often we just report, total population performance, and we don't kind of dig down and look at, systematic biases within the model. You could say your model has 99% accuracy. It's almost perfect. And maybe that 1% is always a pregnant woman. The car stops for everyone but pregnant women. And so, I think we need to, to be able to trust a model, particularly for those people who are, the minorities in the population, you really need to make sure that you show that you're thinking about those people, and you show that you're not systematically disadvantaging them as a result of the application.
Yeah, thank you very much for the comments. Yeah, any other panel members want to comment about the evidence, trustworthiness? Jonathan?
Yeah, sure. So without wanting to state the obvious, I guess the level of evidence is somewhat task dependent, right? And I think if we think in, healthcare, up until, even till today, I think something like 70% of all FDA approved medical devices are for imaging. And the reason for that is that they have a very narrow scope, and it's very easy to reach, a bar of evidence. So for example, show that your model reaches a certain level of sensitivity and specificity at detecting, tumours in images, or, cardiac conditions from ECGs, etc. So, historically, I think like for those very like closed form diagnostic tasks, it feels like the bar of evidence is kind of obvious and within reach. I guess maybe where things get interesting is, a good example is probably AI scribes. So the risk with some of those sorts of systems is that you have a creep of the scope of them. So, for example, if your AI scribe is literally just writing down what you as a clinician are saying, then you could make a reasonable argument that the only evaluation metric should really be its ability, its accuracy in scribing what you're saying. But then, as you shift into maybe the algorithm is summarizing what you're saying, then you're kind of blurring the line, and the algorithm is sort of doing some of the clinical decision making there. And then you get into a very blurry category where the algorithm is actually maybe making recommendations for treatments, right? So yeah, it's interesting. I think one of the challenges is trying to define clear boundaries on the scope of these medical devices. I know that the MHRA has got some interesting innovative schemes like the AI airlock, where they're trying to address these issues in collaboration with industry partners. But yeah, I'd say that's in order to define the level of evidence, I think one of the first things is really trying to have a clear boundary on what the scope of these systems is.
Yeah, we still need the language to communicate this, right? So, and also, probably now we can open the floor to the audience. I think I welcome two kind of, one is comment, right? So you can, but just try to be brief, and try to comment on your views about the kind of output that we can produce, or the level of evidence that we may provide. Or you can also ask questions to the panel members. Probably you can keep one mic over here, and can the volunteer come here to help us manage the question from the audience, or comments, right? So question and comments, both are welcome. Please, yeah, anyone.
Thanks very much. A very interesting discussion to listen to. So looking at sort of question 2, you think about autonomous cars, a human. You give a driving test, you give them a license, and then they have to get insurance. Do we need to have some sort of form of, AI liability insurance? Who's going to underwrite it? Is there something in that sort of area that is necessary to actually achieve the commercialization and actually push through all the research and innovation into something that's tangible for consumers?
That's a very good point. It's very expensive to insure an AI system, if possible, right now. So I like to use the word assurance for insurance, but actually it turns out in order to get insurance, you need temporal data. So in a way, it needs to be deployed collecting data before an insurer will calculate the risk. So it's a very good point. I think once we get to the point where insurance will underwrite systems, that's when we've reached the level of requirement, I think, because they're very cautious. So.
So in the shipping industry, they created insurance for seafarers stranded in various countries, and most of the shipping companies, they just routinely started stranding their seafarers because they knew that the insurance would pay out, and they just accepted that cost. So maybe it's not a good idea.
Fair enough.
Yeah, thank you for the comments. Yeah.
I heard that there's also in shipping, there's also an insurance on crates, containers going in, and you pay the average. So people gain that as well by having empty containers.
Yeah.
My question was to address question 2. I think as an early career researcher myself, one thing I struggle with is perfection. And I think hyping addressed it on how, as academics, we want to make sure something is the best. And I've heard from the industry side, it's important that something is deployable and impactful. But now what I want to ask is, how much do you value a prototype? And I'll give the analogy of a chef. if a chef can cook a very good meal with basic ingredients, if you put him in a 5-star restaurant with better equipment, quality ingredients, he's going to produce even better. So if I have an algorithm or a model, but it's not complete because, one, I don't have the resources or I don't have the data. But if I approach an industry and say, okay, honestly, it's not the best, but there's the potential if I'm backed or if invested in, not that it's a guarantee, but we could make something even better. So that's what I want to ask. How would we approach or pitch well to the industry as early researchers?
Everybody feel free to jump in. I have too many friends starting startups, failing startups, trying to launch startups. One thing I can tell you is that no matter how perfect they have tried to perfect their output, it's almost never what actually continues to be part of their product. So you should do the best you can because you're proud of your craft, but I would encourage you to deploy or launch or iterate as many times as possible. As part of being in academia, which I was for a good 15 plus years, I think that it's really important not to be too complacent and say, no, first I need to do this, and then, no offense to standards and evaluations, we need all of them, right? Thank you. But if you want to get it out there, your best product is going to be one where it is backed, people will use it, and then you will get that 5-star restaurant that you can then cook. So my major suggestion to people who are interested in getting things out there is you have to go out there and talk to people. Just do it.
Yeah.
And if you think you're doing a lot, you're probably not doing enough. Just keep doing it.
I think I want to comment on your question about something. I attended a DeepMind talk about this. I do read the question. He mentioned about alignment of incentives, right? So that's related to earlier Julia raised the question, what the industry needs, right? In order to sell something, you need to understand first is what do they need? What's their KPI? If your solution can help them to address their needs or help them to achieve their KPI, they will definitely work with you. I think, of course, it's difficult, but you need to know what they want, and then you need to pitch your solution, at least potentially solve it. If you don't even know what they need, there's no way that you can sell your it's just like customers, right? If you don't know what the customer wants, you can never sell anything to the customer. I think that's a starting point, I think. Only by knowing what they need, you have an opportunity. But if you don't know it, you have zero opportunity to sell your solution. Yeah, first question? Also two here, right?
Maybe another quick thing. The way you approach perfection with your science or your engineering, you may read lots of papers, you may push lots of code. Take that same energy and put it to talking to people.
Yeah, because that's what you need, right? Because you want to be perfect, because you are satisfying your needs. Then why should they pay for you, right? So you are doing for yourself, right? So yeah, please, another question.
I have a comment again on the first question here, and carrying on from what Hyping said. So that's really so true. The product market fit, basically. So finding that fit, and perhaps in today's world within academia, there is a lack of entrepreneurial skills. So that's like a big gap that perhaps many universities are trying to close by business development or knowledge transfer offices, but it still sort of lags behind. So I think there is a lack of entrepreneurial skills there to bring things out and to ensure that product market fit.
Before going to, any comment here? Yeah, please.
Just to comment on that. So only recently did I join NPL, and I was, a pure academic before. And I've realised now working at NPL it's a journey. You don't just turn up on, this is what I thought, right? You turn up, knock on the door of the company, you go, by the end of the day you'll be working together. even for MPL, it's like months of talking to them, building up a relationship, getting to understand. And I hadn't realised that before, so I just wanted to let you know that my realisation in that area.
Yeah, I want to add another analogy. This is quite like industry and academia. It's like dating, right? So if you want to pursue a girl, a boy, it's not like, okay, I like you, right? So can you marry me? Right? It's not like that, right? You need to know what they like, what they need, so that they may want to have a relationship with you. But you can't just say, okay, I want to work with you, I want to have a relationship with you. You need to know what they like, what they want, right? So I think that's quite important. It's mutual communication, is two-way, right? So can we go to the next question? Yeah, comments or question?
I think it's both like a comment and a question at the same time.
Yeah, please.
In the more technical side, I think kind of we need a scaling loss for multimodal AI. One of the reasons why LLMs are kind of like were the promise like 10 years ago is because people start doing experiments and start creating curves with the amount of data that you have. And they will say, yeah, in the future, we are going to scrap all the internet and we will get a nice model at the end. With multimodal AI, you get some papers that if you add more modalities, you get better results. You get the same topic, same paper, kind of same problem. No, the modalities are clashing, and you get worse results. So how do we standardize these methods so we can get the scaling curves, and we can tell people like, yeah, maybe right now we don't have enough power to get like the accuracy that you want, but maybe in 5 or 10 years, multimodal AI will be the solution for this.
Do you mean, how do you create the image net for multimodal AI? Is that what you're asking, or
no? It's just that kind of like for many of the applications, you don't have like really like a scaling law. It's like, for example, in biology, if you keep adding like omics, for example, what's going on? How does it's kind of like interacts with the number of points that you have. Mm-hmm. Like Aaron showed, like 70 million points that they have in COSA AI, enough for what you want to do, or how do you predict that? How you do?
Yeah, I mean, I'm not. It seems strange. I'm not a multimodal AI person, so I'm not the right person to answer this. But it is something that kind of, makes me, I kind of think about all the challenges. I think you're very brave people to be thinking about multimodal AI because, you're just increasing the challenges that you have, by many, you're just adding all these dimensions, you're reducing the amount of data available to you, and I still, struggle with the idea of what the modality is. We share our chest X-rays as DICOMs, this, custom imaging format, which contains lots of metadata. We share the same data as JPEGs, and the community is all about the JPEGs. Even though the DICOM is better quality data, much more informative, the community works with JPEGs because that's an easy format to work with. So even when I start thinking about what a different modality is, I haven't got kind of a clear idea about that in my head. Sorry, it doesn't answer your question.
I have a very functional answer. We love evaluating models. What we don't love about evaluating models is that they're not always callable via a simple API. So we still have to boot it up. We still have to process the data, ingest in a particular way. I think in order to find potential scaling laws, my impression is that we have to still explore architectures. And so if you want to explore architectures, you need to be able to test a bunch of these things with increasing amounts of data, or at least some ablation or some subsets of data. So exactly. So basically my simple functional answer is please put all your models on Hugging Face or something with an endpoint I can call.
I think one other comment is just speaking about healthcare, for example, there's very limited multimodal data. I mean, even if you start off with very large unimodal data sets, once you start looking at the multimodal space, you lose a lot of the unimodal data. So I think there was one recent paper that looked at scaling laws for, I think, chest X-ray foundation models. So there's some emerging work in this area. But I think when it comes to the multimodal space, it's still very difficult, at least in the healthcare domain.
Great. Yeah. Well,
A rubbish answer is you're only as good as your worst mode. So you probably that's probably a bound, isn't it? How the mode. So if it's imaging or text, you get different scaling laws for each mode, and then like one of them will be your bound on what can be achieved, I imagine.
So I like that approach, but at the same time, it's like you need to prove that adding more modalities, you are getting an advantage. So it's kind of it's kind of like would be nice community output for the future. Like if we can develop like this scaling laws, so we can tell people, it's going to work at some point. It's going to.
I mean, I agree that the scaling laws are why we're in the place where we are now, right? Because the scaling laws were shown, and then that provided impetus for investment and building larger and larger data centers and things like that, yeah. So it's important.
It also depends on the task. Like there are some tasks where multimodal learning actually doesn't help. We've seen that in we have one project on AI for IVF. So we have images of embryos and clinical data. And for the tasks that are really morphology dependent, that really depend on the image, the model actually eventually starts ignoring the clinical data. So I think we also need to think about which tasks would benefit from multimodal learning so that we don't waste resources eventually.
Okay. I know this can carry on until the World Cup, and probably we can stop here, and we still have the networking reception, and you have opportunity to discuss many of the issues together. So now let's thank the panel again, and also, of course, the audience as well, right? So for this very exciting discussions. Then